Hello everyone, I'm not here today, so I'm leaving you this lovely video. Hopefully you watch it and hopefully it is helpful. Let's go ahead and get started. I hope that you all watched this, or not watched, but saw this piece of information on Canvas. So I made a decision to change things up a little bit. You can read that there, but to what we're doing today is I'm going to just in this video go over some problems for you on 4.1 and 4.2. And then you'll just basically have a work day to work on any problems that you haven't finished yet in Unit 3 and 4. There's a couple of you who are completely caught up, but most of you are not. So please use this day productively. And if you are all caught up, feel free to work ahead and see what you can figure out on your own in the next assignments. Instead of covering new material today, we'll cover new material on Monday, and then we will review on Wednesday, and your test will be next Friday the 15th. So that has been bumped back one day from our original schedule. We will have to make up for that sometime by doubling up on a section that I have maybe just planned one section. We'll have to do two sometime during fourth term, but it's going to be okay. All right, please go to your homework assignment on paper. And what I'm going to do is just walk you through 4 problems on this paper. So these black circled ones are required, but I'm going to do a couple that aren't required just to give you an idea of what you're doing. So I'll do numbers 6 and 18 on 4-1. And then on 4-2, I'll show you number 20. And then 26 is a required one, and it's a pretty difficult one. So I thought I'd show you how to do 26. So go ahead and follow along. Remember, you can pause this video whenever you need to. So here is problem number 6. Okay, so remember, you can pause this whenever you need to. I'm just going to walk through each of these problems. So in number 6, we are just simplifying this problem, and I'll go ahead and tell you the answer ends up being 3. All this whole line of gunk ends up just equaling 3. So let me show you how that's done. I'm going to start by changing cosecant to 1 over sine, and then I'm also going to take the cosine of negative t and rewrite that as the cosine of positive t. We can do that with cosines. So this is 3 sine to the 3rd over sine. I get over sine because cosecant is 1 over sine. So those two things multiplied together equal this new line. The last time I made a video for my A-Day classes, they complained that my pen was clicky and annoying. So I'll try to write softly, but I apologize if the pen is clicky. Just deal with it. Okay, I'm not going to do anything to cosine squared. Remember, I told you that this can be written as cosine of positive t. So this term is 2 cosine squared. Cosine times cosine is cosine squared. Okay, in the first term, sorry, I keep bumping my screen. In the first term, you can reduce these 2 sines, and you're left with 3 sine squared. You can combine like terms next, and you get 3 cosine squared. Factor out the 3. You're left with sine squared plus cosine squared. That's one of our Pythagorean identities, and so that's 3 times 1, which is 3. Done. Okay, number 18. So number 18, I would opt to use conjugates on this one, multiply by the conjugates. I'm going to go ahead and tackle the right side just because of this. Since I need to simplify this first, I'm going to just do all of my stuff to the right side. So this changes to 1 plus negative sine of x, which I can actually just write as 1 minus sine of x. Okay? So now I'm going to multiply both the top and bottom by the conjugate of the bottom. Why did I choose to do this? Really, it's because there wasn't a whole lot else to do. I can't change anything to sines and cosines because it's already that way. So I'm going to multiply by 1 plus the sine of x on both the top and the bottom of this fraction. Okay, that gives me cosine of x times 1 plus sine of x over 1, when I multiply 1 minus sine of x and 1 plus sine of x, I need to FOIL or distribute or Punnett square that, and you end up with 1. You end up with 1 plus sine of x minus sine of x, so those terms cancel out, minus sine of x, so minus sine squared of x. Okay, next. This is a Pythagorean identity. If sine squared plus cosine squared is 1, then if I subtracted sine squared from both sides, 1 minus sine squared would equal cosine squared. So now this cosine squared cancels out with a cosine in the numerator. So I'm left with 1 plus sine over cosine. And that's what our left side is, and we're done. Happy day. Again, pause if you need to go back and figure out more of that in slow motion. Okay, number 20 is now on 4-2. So this one is using your difference of cosines identity. So if you come over to your notes, the cosine identities are here. So if I have a cosine of two terms being subtracted, I'm going to write cosine cosine of each angle plus sine sine of each angle. So this is going to be cosine theta cosine pi. Since this is minus, we change to plus. I don't know why my screen keeps jumping like that. I'm sorry. Plus sine theta sine pi. And again, we're manipulating the left side to try to get it to equal negative cosine theta. Okay, I don't know what the cosine of theta is, but I do know what the cosine of pi is. So here's my unit circle, here's pi, that's the coordinate negative 1, 0. So the sine is negative 1 and the cosine is 0. So this is cosine theta times cosine pi, which is negative 1, plus sine theta times the sine of pi is 0. That means this whole term is gone because it's multiplied by 0. So we are to the point now where we have cosine of theta times negative 1, so that makes negative cosine theta. Done. All right, the last one. This one's pretty tricky. Let's see how it goes. What are we going to do? I would start by working on the right hand side, and the reason is cotangents and tangents can always be changed to sines and cosines. It's possible to work something out on the left hand side, but I'm going to go for the right hand side. Okay, so first thing I will do is write things in terms of sines and cosines. So this side of the equation is 1 plus cosine alpha over sine alpha, and then the tangent is sine beta over cosine beta. You need to resist the urge to cross out those sines and cross out those cosines. You can't do that because the angles are different. If you had sine beta over sine beta, you could cross them out, but they're different angles, so you can't do that. Okay, go ahead and write this over 1 minus cosine alpha over sine alpha times sine beta. There, that did that again. sine beta over cosine beta. Okay, this is ugly, but the next thing I want to do is realize that all these things here are being multiplied. So this is essentially one term, and the 1 is one term. So I want to add these two terms together in the numerator. I have to do that by finding a common denominator. So my common denominator is sine alpha times cosine beta. So I'm going to multiply this 1 by sine alpha cosine beta on the top and the bottom. So that gives me sine alpha cosine beta on the bottom and sine alpha cosine beta on the top, plus, we don't need to change this fraction, cosine alpha sine beta over sine alpha cosine beta. Okay, now what you have next is two fractions with a common denominator. So go ahead and add those up, and you have sine alpha cosine beta, and then you simply rewrite this two numerators. So sine alpha cosine beta plus cosine alpha sine beta. So we've got sine cosine of different angles and then cosine sine of those opposite angles. So if you think back to your identities, this is going to be a sine identity. So sine of alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta. So we can go ahead and write this whole numerator here. We can write this numerator as sine alpha plus beta. Cross that out. Okay, next we're going to do the same thing to the denominator. So our common denominator again is sine alpha cosine beta. Multiply the 1 by that on both the numerator and the denominator. So sine alpha cosine beta over sine alpha cosine beta minus cosine alpha sine beta over sine alpha cosine beta. Okay, again, we have a common denominator. So add up the numerator. Our denominator is sine alpha cosine beta. Our numerator is sine alpha cosine beta minus cosine alpha sine beta. And this looks just like the other numerator except that it has a subtraction. So this is going to be the same thing as sine of alpha minus beta. So let's write down where we're at. We've got sine alpha plus beta over sine alpha cosine beta divided by sine alpha minus beta over sine alpha cosine beta. Next thing we'll do is multiply by the reciprocal. And I think you can probably see what's going to happen. This denominator and this numerator cancel out. Final answer, sine alpha plus beta over sine alpha minus beta. And if we can look back where we were at, that's what we were supposed to get. Done.